The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. We're part of Hawaii Tracker and bring you guys another Hawaiian Volcano Tracker update. Today on October 5th, 2023, our volcano has started quaking once again, and so we'll recap what's going on with that. But first, how are you doing today, Dane?
Oh, it feels like August though, with how hot it's been. But yeah, we're little bit of interest coming up with these earthquakes, so got a little bit to talk about today. How you doing, Phil?
Doing all right. Yeah, it's interesting to note that. It's a little bit like August with the temperature, but it also feels a little bit like August with the earthquakes, to be honest. Earthquakes kind of in the same place, starting things up. It's a little bit similar to what we saw in the ramp up to the September eruption that we just had. So we'll see that a little bit of deja vu this week here. Right. So we'll get into all that here. Dane will be leading discussion in the chat, collecting questions for us to answer as we go along, as usual. Anything else, Dane, before we get into it here?
No, I think that's it. We don't have a whole lot of videos or photos to show today, so it's going to be mostly data and just looking at, the recent trends and stuff along those lines. So, yeah, let's get into it.
Yeah, for sure. And just one note that we were once again missing our ASL interpreters this week. They are still on vacation, so hopefully we'll have them back next week. And those of you guys who do need the assistance can try the captions and just have to navigate the errors that come with it, unfortunately, this week here. All right, So let's switch over to our Hawaiian volcano summary. and start off by showing you guys this plot. So in our Hawaiian volcano summary this week, you can see the earthquakes on Kilauea summit have picked back up here over the last few days, reaching levels of 150 earthquakes per day today. This is after about 2.5 weeks of lull, which included the 6-day eruption that we had here at the beginning of September, and the recovery period since then. So really within the last month of time on this graph, we can see the buildup to the last eruption, where it peaked at around 200 earthquakes per day there. And you see how that level was sustained for 1, 2, 3, 4, 5 weeks at least. More before here because the graph doesn't quite go off there. So we see we're just coming into this now. You might expect this activity to ramp up a little more and sustain itself to match that pattern from before, building enough pressure to finally break through towards the surface. However, these events in this area don't always create eruptions. Sometimes they're just intrusions. So we'll have to wait and see what actually happens there. Looking at a map of where these earthquakes are located, here they are in this cluster south and the southwest of the Caldera. This is that same area that we saw activated in August and also back in 2021 in August. In fact, we'll get into that in our full update here. So similar areas before, you see not so much around the summit, Caldera area itself. It's a little bit more to the south and really nothing along the east rift zone anywhere. The southwest rift zone, neither as well. However, this area that we're highlighting here is sometimes considered part of the seismic southwest rift zone. So there's some details to pull apart there in our full update. So what I did here is just try to summarize. Here's a cross-section of this area that has our main South Caldera reservoir, our shallower Halemaumau reservoir, and other seismic southwest rift, volcanic rift, east rift zone over here. And I've tried to just plot on here. It's a little bit hard to see these orange clusters of where the earthquakes actually are today. So to make it a little easier, let me flash this other image here where I just dim the background. You can see the earthquakes a little bit better. So you really see that these earthquakes are in this area of the seismic southwest rift where it intersects the South Caldera reservoir and then upwards from there in this western part of the summit. So to see earthquakes in this area is not unexpected. That's why we keep seeing them again over and over and over again. It's really right next to this big South Caldera area and part of the buildup sequence that eventually allows magma to break to the surface and eruption at Halemaumau like this. So just to note, once again, the earthquakes that occurred in the same area at the end of August this year led to an eruption of Halemaumau that was actually offset over here to the east within the main caldera. So that's the summary of what the earthquakes are doing in Kilauea. We have to wait and see what comes next. It'll likely go on for at least a few more weeks here. If it comes up a little faster, that would be interesting as well. But certainly we're just starting the build up to the next eruption here. On Mauna Loa, here's an earthquake map of Mauna Loa summit. Everything is very quiet. I have a couple of deep earthquakes, but really it's doing its normal thing, resuming its the magma is recovering, rebuilding pressure following its eruption in the end of 2022 here. And that's the Hawaiian volcano summary for the week. A little bit of action to get into here. So we'll start off as usual with our volcanic hazard summary. So let's share with you guys the VOG Measurement and Prediction Project VMAP forecast. Here is that forecast on the VOG dashboard. And let me get it playing for you guys. So what really helps is that the SO2 emission rate is only 150 tons per day. That's low for the volcano. So most of the VOG is stuck close to the summit areas of Kilauea in here, or a little bit further to the southwest in this Pahala zone, upslope Pahala up in here, potentially blowing down into Naalehu or into Ocean View, these areas all through there. This is relatively a little bit of gas for the volcano, although at these low levels for the volcano, they are still exceeding industrial standards. Therefore, if you're sensitive, you should always be taking precautions in downwind areas here. However, not nearly as bad as we expect it to be when a volcano actually does erupt again, as we saw back in the beginning of September here. So moving on from the forecast, just pretty straightforward. Here is our purple air citizen science monitoring air quality map, and everything is in the green as expected because that's the stage we're in here today. Moving on to our monitoring from Kilauea. So we had an update come out on Tuesday, our normal weekly updates, and Kilauea was not erupting, no significant changes, and really nothing else to highlight in this update from Tuesday. What's really unusual is that today, we got another update. So we now have daily updates starting today as a result of this increased seismic activity on Kilauea. They note the volcano is not erupting. However, the area just south of Kilauea summit is currently showing signs of elevated unrest. Still no unusual activity along Kilauea's east rift zone or southwest rift zone, and daily Kilauea updates from today onward, as long as the elevated activity continues. So that's the summary there. Observations, they note, the rates of inflationary tilt increased 2 days ago in the area just south of Summit Caldera. So we'll come back to this 2 days ago. Earthquake rates beneath the summit region have increased overnight from less than 10 earthquakes per day to over 140 earthquakes in the last 24 hours. Most of the earthquakes are occurring in the region south of the caldera at depths of 2.5 to 3.5 kilometers. That's 1.5 to 2 miles below the surface. The trend of the seismic activity parallels, but is slightly south of December 74 eruption vents. This is interesting. I'm not really convinced why this needed to be mentioned, but that does give you the location of it. SO2 rates remain low and were measured at a rate of 150 tons per day on September 25th. So no new measurement in the last week. This is still the week prior measurement, but no reason to suspect anything different, even giving the standing stationary SO2 monitors. Nothing in the rift zones. They note the hazards of gas, and that's basically the text that we have from today. So that's what the USGS has put out and their report.
Would that be the
data?
Sorry, would that be the return of yellow plus, essentially, as we call it?
Yep. If you're using the yellow plus scale, where we count that as when there are yellow with daily updates, then yes, it's yellow plus. Whereas, or what sometimes we call regular yellow is just weekly updates, right, as is the standard for the yellow advisory.
Right, but it seems to be a way that USGS is signaling that elevated unrest is the switch to daily updates, even though it's inside of yellow. So that's why we have the yellow plus, just to denominate the two, essentially.
Right. Yeah. So that's our unofficial little
unofficial.
I don't know. It's not exactly. I'm not sure what the right term is there.
I don't know.
Yeah, our little addendum to the
right,
scale there, sticking yellow plus. So, all right, let's look at the data in different time intervals, starting with this last week, where pretty clearly you can see earthquake counts for the last week went from here less than 50 per day to almost 200 per day showing today. Now, note that this is the entire map area of Kilauea, including Pahala. So this is when I mentioned the numbers at the summit, they're going to be slightly less than these, since this is a larger area here. Within their internal software, they can highlight different areas and count earthquakes in just that zone and have these kind of plots for anywhere on their map. Whereas on the public side here, we're stuck with predefined boundaries and predefined plots here. So that does help us keep the comparison standard every time, because we're always measuring the same thing week to week to week. But it does skew the numbers upwards a little bit to 200 here, for example. So earthquakes are climbing up really high. You can see they really started off yesterday, climbing to over 100. The day before it was coming up a little bit closer to 50, but it's really within the last couple of days here that's really come upwards. Looking at the depth versus time here, that same 1 week period of time, our deeper zone of Pahala earthquakes, these blues, seem fairly steady, although there is a cluster that does, a couple clusters that do come in here at a similar time as the shallower stuff. Really, it's the shallow background here. Then you start seeing here the ramping up, and really the onset right there of all these big events. So it'll probably help if I zoom it in for you guys a bit. So there you can see that shallow band of seismicity coming in strong here within the last couple of days compared to the previous part of the week here. So for the last week, the tilt looks like this. So you can see there was somewhat of a deflation-inflation looking cycle here. And as we often have it on the near peak of the inflation cycle is when we start getting this elevated activity as well. So that's interesting to note. That happens to be when it likes to be triggered there. For lava depth over the last week, our data is not coming in steadily here, but what you can see is a similar patterns we've seen in the past. Not a whole lot of change going on there. Yeah, but we can't really see in the last couple of days. Within the last couple of days, nothing really alarming within the lava depth. The only thing you can really look for with here is if the crust might be raising because of some injection of lava, something like that. And none of that's happening. It's all deeper in the ground. We're talking about 1.5 to 2 miles still beneath the surface of the ground. So that's a lot of rock in a way still. and no effect on the surface yet. Okay, here's our plot of earthquakes, and this is just to recap. This is the square that's getting counted for the earthquakes in that plot. So we're catching all these Pahala ones as well as all the Kilauea ones in the southwest quadrant here, as well as all these south flank earthquakes, which are still ongoing at their normal background rate as well. What's more important is that here in the rift zone, there's really no sign of any pressure building anywhere through there. And that's what matters for people who live down rift, where we know that the volcano will erupt again someday, but it does not look like this is the sequence that's leading to it quite yet. Right, so shifting gears to the last month. So we see here that last week would have just been this ramp up right in here. We can now compare our levels to what we saw in the buildup prior to the September eruption. And as we said, that one lasted longer and reached higher rates than we're seeing here within the first couple of days that we've seen so far. Looking at the depth versus time once again, but not for the whole month, you can see that band of earthquakes prior to the last eruption here. The eruption begins, it lasts some amount of time like that. Then you have some background activity returning, but it's really all the way here at the right end. That's that new activity that we're talking about. And so you can see that there's still quite a lot of adjustment happening during this entire period. It's just the absolute numbers give us a little better insight when you look at it at this bar graph like you see up here. Looking at the tilt for the last month, there it is. Here's that most recent inflationary bump that we're cresting on right now. And that's part of this overall pattern of inflation since the 15th or so, which is the day before the end of the eruption, where it's been coming up pretty steady since then, with these superimposed, it looks like deflation-inflation cycles upon it. Interesting how they have different lengths here. Maybe this is like a couple back-to-back. It's hard to tell exactly, but the pattern that I pick out as being more important is that steady long rise there, where it comes from in a ballpark of -10 microradians and ends up at about positive, call it 8 microradians or so, right? So you're looking at 17, 15, between 15 and 20 microradians of inflation, which is a good amount there for the summit. As expected, it's almost like you've popped a boil there, and now it's able to adjust to the repressurization from below there. So that's noting magma collecting under the summit area. This is Uikahuna Station pointing towards Hale Ma'uma'u. But we also have to the southwest, the Sand Hill Station. And this is also for the last month. And once again, this station is now showing two components of the same station. The blue one is the one that points towards Hale Ma'uma'u, and the green one is the one that points towards the South Caldera, Kanakakoi area, where we have seen this buildup. So here is the last eruption, and here is our current events happening now. And I might note, if I put these last two plots up together here, we see a very similar pattern. We're right around the 15th, 16th, we see this turnaround from this deflationary trend to more of a long inflationary trend like that. And it's really right in here where it really seems to take off beyond that trend even higher. The green component is the one that's east of Sand Hill, not the summit itself, whereas the blue one is the summit itself. So you can see the summit is picking up some of that. The summit, Hale Ma'uma'u center of the summit, is picking up that inflationary signal a little bit more strongly, but still parallel to what you see here. And it's really this green component that's really off the charts here for us. And I say that because if you note, this thing is ending up here at around 30 microradians of tilt. And it begins, if we pull it back to just 1 week ago, right in here, you're looking at, that's maybe a -2 or something like that. So you're looking at 30, 35 microradians within 1 week here, just on this one component east of Sand Hill. So certainly quite a lot's happening. This is the same pattern as we saw prior to the eruption last month. And so let's recap what that looked like. Here is a shot of that same Sand Hill station. This is August 12th through September 10th, the day the eruption actually began. It kind of, this extra line of green here is eruption beginning on the right. What you might note is that these components also rose quite a bit. They had these extra earthquakes causing extra little wiggles here and little offsets coming up and down. But note that it kept going up and up and up and up and didn't actually let up going up until the actual eruption occurs, right? The same thing is true here. And the other component that shows a similar pattern, just not nearly as dramatic. Now, to come back to what we're seeing here today, hard to see, but the blue one is more obvious. this blue line has started to come down already there. And this is coincident with a peak of these earthquakes right there. And if you note, the green line hasn't come down yet, but it's actually, I'll trace it so you can see it a little better perhaps. It's actually become a little less steep. So it was coming up fairly steeply, and it's still going up steeply, but it's letting up a little bit. And so it looks like it might be doing one of these flattening out deals, and we just have to wait to see since we're mid-event still right now with a swarm still ongoing over there. We'll come to that here shortly. So a little bit different than before. And what might this look like? So I'll throw out another candidate, another plot here. This is the sandhill tilt plot once again. Now we're looking at 2021, August 10th to September 9th. Right? So this is 2 years prior to the last one. And in this case, you see there goes a sandhill station with these two components. This was actually an inflationary event, so this didn't erupt until about a month after this occurred. Right, so magma had injected into this area. It comes up pretty quickly right here, and then it starts to go more slowly, and then eventually it flattens all the way out. What was interesting in this 2021 event that it did it twice. So here a second time, you see it coming up pretty steep, and then starting to round over and flatten out, and eventually flattens all the way out. So the question is still up in the air now, whether what we're seeing today here might be one of these. Is it going to flatten out and is this just an intrusion? Or will it wiggle its way back up and resume a pattern we saw previous to the last month's eruption, and perhaps more quickly build to an eruption, right? Because the difference being, when we saw this build up last month, that was about 2 weeks before lava came out of the ground, right? That's the example of it actually building to eruption. Whereas example from 2021, it took it a full month of doing nothing after the event ended for it to restart its build up to erupt eventually on September 21st of that year. So a little context there, no hard answers, of course, just some patterns to compare. One is an intrusion, one is an eruption there. So far, we obviously are intruding since lava hasn't come out of the ground, nothing is erupting yet. And the fact that we're seeing it turn over, to me, makes it, at the present time, be leaning towards an intrusion more so than an eruption. So wait and see what comes next. Of course, you can't predict the future, just trying to monitor what's happening in these last few data points we actually can see in here on this sandhill station. So note that area of increase right through there. We looked at the tilt at Pu'u'o'o crater before. It's doing something really funny over here. I still don't believe this is actually a real signal. I believe this is some kind of electronic fault or something like that. Or perhaps the crater itself, where the instruments installed, collapsing or moving in some funny way. It's something unusual is happening. It's very localized there. And to reinforce this point, I've pulled down here the next tilt station down a rift zone at Jonica, and you can see that it is straight deflating all the way down. In fact, not only that, let's look at the scale of this thing. We're going from 10 microradians-ish to all the way down there is -7, we'll call it, right? So maybe 16, we'll call it 9, this is -7, 16 microradians that's been dropping down over the last month. So this thing's sagging pretty good, sagging and tilting back inwards, and no sign of any magma anywhere in the rift zone still, which is why this seems like an anomaly, whatever is happening here at Pu'u'o'o crater. Still not going to hide it. There it is. We'll hopefully follow up on that at some point and see what it actually is. But I'm not concerned at this point, given it's an isolated signal and everything else seems to say the opposite from that. Okay, we're still looking at the 1 month long period, and this is our lava depth. Not so much data here at the end, but you can see the pattern where it came up during eruption. One little wiggle of adjustment post-eruption, and then pretty steady, if anything, maybe slightly coming down, but no clear, obvious change, right? If I highlight once again this segment of the screen and I scroll it down real quick, no change, no change. In our gas measurement, there's no gas measurement of this last week here, so it's still showing our background of 150 here, close to 0. All right, we'll zoom out to the last year. There's a gas, same pattern as we've seen, nothing really new there. Earthquake counts. Now we see something different. Earthquakes per week are showing up now above the background at the very right end of the graph here. This was a build up to the last eruption, the one prior in June, and one prior in January. So you see that all of these last multiple weeks. Multiple weeks, this one almost 2 months here. This one might have been about a month. So we're just starting off here, and we would expect it to intensify over the next week at least. GPS over that same time period. Zoom all the way over to the right, because that's that last week we're in right now. And you see that the GPS line might have been fairly flat. Maybe it's coming up a little bit wiggly. There's definitely some small scale adjustments happening there. This is a line that's measuring north and south across Kilauea Caldera. So if the summit is filling up with magma and getting stretched apart, this line goes up. If it starts sagging in and contracting, it goes down. And if it basically stays the same distance apart, irrespective of going up or down, then you see it be flat like this. So obviously there's all kinds of components that can affect which way it's moving, including the south flank, the magma injecting, the different blocks and how they've been primed from the last eruption, which way they've wiggled, how they're currently sitting, all that kind of stuff. And without knowing all the details of where those boundaries are, we can just say that's all wiggling in there and adjusting as magma is repressurizing under the summit. And it looks like something might have possibly caught because it had not continued expanding. When it's expanding, it's basically moving out of the way. It's making space. Magma's got somewhere to go. Everything's good. If the magma is still coming in, though, and the volcano stops expanding, then that magma is going to be able to build more pressure. And that might be part of the signal we're seeing here as far as earthquake swarm being some little blockage or something happening. And that small scale of block wiggling this way or that way that basically allowed it to stall its stretching until the pressure wiggled it back into some more favorable configuration there. So we'll wait and see. This is obviously data that gets corrected here at the very right end of this graph, as we've talked about in the last few weeks. So we'll see how this ends up stabilizing or being corrected. But it is interesting to note that slight change in pattern there, which we've seen before. You see it get flatter a few times in the past, sometimes before an event, sometimes not. So that's par for the course here. Moving to the rift zone at Pu'o'o. This is that similar kind of north to south across the rift zone measurement. And you can see here straight down, no change over the whole last year here at Pu'o'o. And this is one of the signals that we use to reassure ourselves that tilt meter signal is really isolated. So this one is opposite, showing just contraction in the rift zone, as all the other ones do as well. Earthquakes of depth versus time, really intense over the last year. I won't dive into the details of that, or the last 5 years here, where we're going to zoom out a little bit more. Lots of earthquakes all the time. Been really active 5 years for Kilauea. Here's a 5-year earthquake counts. And we're just coming off earthquakes per month being high here in August and September with our most recent eruption. And we're going to come up here and look like there was no gap in between because it's been less than a month since this last event. And this is an earthquakes per month plot. So this will be interesting to untangle in the future here. GPS is why I wanted to show you this 5-year plot, because here is that similar north to south across Kilauea Caldera line. And clearly it's been expanding. The trend is up over the whole 5 years, right? With these little interruptions from eruptions that seem to relieve pressure temporarily. There, 3, 4, there's our 5th one right there. But what I really wanted to point out was how you can see that this first era of extension, average it out through about in there, right? Through about the end of 2022, right? This is when Mauna Loa erupted. It was still extending, but it was doing it at a much slower rate. Since Mauna Loa eruption ended and Kilauea resumed back in January, it's been extending at a much faster rate than before that. So this is interesting, and maybe this is part of why we can help explain why we've had 3 eruptions this year already, right? In January, in June, and in September. And maybe it's expanding more because of this increased supply rate. Might be one example of why this might be happening, and certainly that would be consistent with seeing more eruptions come to the surface. So interesting, and we'll see what happens here. It's October 5th, Dane. You are welcome to set an over-under when this thing might or might not erupt. Last time we were talking about it might have happened before the end of the year. That seems like we could maybe move it up a little bit.
Chat was talking about, I heard a mention of the 17th as a line. That's less than 2 weeks out. So I don't know. I'm thinking let's go with the 27th as the betting line, over under. Think it's before the 27th. You're under. If over, you're over. Right.
We'll see.
We'll see. Go ahead and say over or under October 27th.
Yeah, and as we've laid out, we had that event in 2021 where it actually did a similar thing, and then it basically stopped for a few weeks before it started up again a month later. And we've had ones like in September where it started up and just kept going and fairly quickly came into an onset, which also meant it didn't last very long, right? So that's the other thing. If we have such a short gap between the last eruption and this following one, do we really expect the next eruption to last very long, or will it be even shorter than the ones that we saw? Right? It used to be that if you drive around a national park and you drive past all the signs of eruptions, you pass like Luamanu, that was a 4-hour eruption, right? Kīlauea was another few-hour eruption. So it's historically fairly common to have less than 1 day long eruptions. And so I wonder if we'll keep creeping our way back towards that. And you got to be really on it to catch something happening. So we'll see. We'll see. But for now, we're just raising the background, and we'll see beyond that alert of background where we hit the next gear, right? And what happened in September is we saw levels raised for a while, and then we hit that next gear, and we knew, okay, now it's really above the background. And so not quite there yet in this particular case. And to round it off here with a 5-year GPS, here is the rift zone where you can see that long, steady contraction that's occurred ever since the 2020 first eruption at Kilauea Summit following 2018. So interesting how all those things connect there. I wanted to show you guys first here the 2-year GPS. Not in super great detail, but these are our summit components. And I like to focus on the bottom of these panels. So just to talk through these are now 2-year plots. So twice the length of time here. And there's an east-west component on top. This is east, so up is east, down is west. This one is north, so up is north. And the very bottom one, up, is actually physically up. So that's the one I look at for the most convincing evidence that the ground is uplifting, swelling with magma, not just getting pulled apart from some, because if the ground is spreading apart, if it's just gravity and it's just slumping down, then it should be moving apart and settling down at the same time. If it's getting swollen by magma, it should be moving apart and moving up, right? So that up and down is super important for that reason, to kind of differentiate. When you have something like a big south flank that's moving, it's moving by gravity. Which one is a more important factor at any moment in time? Depends on how much magma is pushing or how much south flank is pulling. So when we see the ground going up here, that's telling you there's more magma pressure. The magma is what's doing the driving here. And you can see that following this drop of the last eruption, it's come up pretty quickly and pretty steeply too. Right? It's interesting. There's a buildup to September. I'm sorry, to June eruption. Build up to September eruption. And here we are building back up again pretty quick. That same pattern is this is Uikahuna Station, but if we look at Byron's Ledge, same pattern. You look at Crater Rim, same pattern. You look at the outlet station, same pattern too. Some really notable vertical marks getting plotted on there. If you look on the rift zone itself, you see none of that. Here's Mauna Ulu, which has some data noise, so it looks really flat, but you can see overall going down. Kananui Ohamo, a slight wiggle, but still overall going down. Pu'o'o, 3 components, going down. Another reassurance there for that bad tilt meter. Kananui Ohamo here, going down. Everything's basically down until we get unless we look at the south flank. Now, this is the area that's close to Kilauea Summit. Now, I'll show you the map here in a minute. But Ahua going up pretty fast. Puhimau going up pretty fast, although the one data point might be noise. Hard to tell there. So questionable, Devil's Throat. Now you're really getting within a scatter, not convincing at all that you're beyond that. So somewhere between Puhimau and Ahua Station there is where we see the center of this swell. So let me switch my screen here to Google Earth. And let me start off by, so what we have on here is we have the earthquakes plotted on here, and Google Earth plots them really small. Apologies for that. So hopefully you can see that to some degree, but we're going to put some other stuff on here as well. So let me find our GPS previews. There's a GPS previews from all over. And I'll just point out to you guys, there's Uikahuna. That one is Crater Rim. That one is the outlet. That one is Byron's Ledge. These are our 4 summit stations that we usually look at right here. Then looking south, Ahua, showing north, that's this one. And Puhimau, this is the one that has maybe noise. Maybe that's the boundary somewhere in there. Coming a little bit further south, Devil's Throat, that's where we see it within the noise, not convincingly outside of it right in there. So just like before, if we were to draw a line around where the extent of uplift happens to be, it's somewhere like this, summit area, not anywhere beyond there. And that's the important thing, not reaching through that area down that way. So GPS, we can do a similar thing with the tilt. Let me pull on some tilt meters here, and some of these I'm going to take off because there's no data on them at all. So there's Uwikahuna. It's showing tilt coming up from Halemaumau area. From here, there is that Sand Hill Station with its two components. The blue points this way, the orange points this way. You can see why the orange one that points this way towards all these earthquakes might be the one that's showing that higher component of rise, the green one here. And further over, Escape Road, not showing any inflation. There's our funny Pu'o'o station, and all the way over here at Jonica, straight deflation. So all good here across the board on the monitoring instruments for the rift zone. Okay, so let's take that off of there. Now, what I wanted to show now, let's see. Well, let's make the earthquakes a little bigger first, so you can talk about those and share that with you guys, because I'm not convinced you can see them on that Google Earth map. So here's a map of earthquakes for the last 7 days from the USGS site. There they are, south of the Caldera area, the main Caldera area being right here. And I often refer to the Great Caldera, the larger collapse structure from an older collapse event of Kilauea back about 500, 600 years ago. And its extent comes out something like this. It goes all the way out to there, something like that. That's the Great Caldera. So really, that's why I say the South Caldera area right through there. That's where it's connecting further over to this Kauai fault zone, into the southwest rift zone, which is seismically here and then volcanically up here. So to lay all that out for you guys, well, first, one other thing, this is the last 7 days. The red ones are the ones still ongoing here. So if we look at what's happening now, let's see here, 25 minutes ago, there was a 1.9. And 4 minutes before that, 2.0, 2.3, 1.9. Those are the events here. Looks like the largest ones are in a magnitude range of 2.2, 2.3, more or less in there. There's a 2.7. That might be the biggest one I see here down in that area. So this is just the last week. If I go back to the last 30 days, that's going to include the last stages of the build-up to the last eruption. And there they are. Most of those dots show up in white. You can see that very same area right through here with overlap, right? Although towards the end of that eruption, we saw that activity migrate and focus upwards here underneath the main caldera as well. So it's a very similar area, very similar pattern as before. One thing to note as well, just since I have this to share, this is the earthquake counts over time. So here's a build up to the last eruption, very steep. It erupts. Earthquakes are almost not occurring. And then here we are today, taking off as well. And this is why I say the swarm is still ongoing. You can see that we still have not leveled off at the rate of earthquakes. And we'll have to wait till next week to update you guys, or sooner. If something does break to the surface, we'll certainly pop in sooner than that. But I would be surprised if that happens within this next week here. So there's the rates of it. And in case you're wondering why I keep referring to the Southwest Rift Connector, here is a plot from Swanson et al. From 2018. This is where they're examining this area of the Kauai fault system. And so there they highlight that outermost caldera fault once again. That's a Great Caldera boundary right through there. And they show this SSRZ, Seismic Southwest Rift Zone, also sometimes called Southwest Rift Connector, which would have a wholly different acronym there. And you know how it has this kind of south-southwest trend, and then it turns more west-southwest once it encounters this Kauai fault system right through here. Right in here is a 74 December eruption fissures. This is what the USGS refers to. So they're talking about the earthquakes being just south of there. That actually, to me, lines up more with a Southwest Rift Connector zone than mentioning something at the surface, because the surface is 2 miles away from these earthquakes still through the rock. So even though it looks like it might be there, those are really two different things since there are much different depths there. Certainly something could come up from this area and migrate to the south a little bit and pop open there. But historically, an eruption from this seismic southwest rift area is rare. This December 74 one is the only one we have on record of that happening. Most other southwest rift zone eruptions are in this network of cracks over here that shoots off the caldera at a shallower depth to the southwest. So that's why we keep calling this a southwest rift connector. That's what the preference is, as noted by Swanson and others in 2018. Similar to the east rift connector, which is also has a similar parallel pattern over here to get around a bend to really get magma towards the Middle East rift zone and beyond. So the cross section that we showed before is this one. When you look at it from the map section, there.
Well, it seems like we're having
a
a little bit
inset.
of a technical difficulty right there. Phil, you back? Can you hear me? Okay, it looks like I can see you moving. You're now muted. But yeah, 1 second. Yep. Little bit of a technical difficulty there. Take this time to remind everybody that we do take donations. They are tax deductible. We do those on hvery/donate. And we do also take super chats as well. Welcome back, Phil.
Thanks. Yeah, I think it's the size of this document on a window here that
I think so. It was like right as
so.
you transitioned, it happened. So yeah.
All right. So I'll share it without moving it, and then I'll try to move it and share a little more there. Let's see if we can get through here. So here's another map inset of that similar area, showing that offset between volcanic southwest rift a little bit further north, seismic southwest rift, South Caldera, Kilauea reservoir, High Mountain reservoir. This is map, you remember. There's a Kilauea trend that's within the caldera itself, and there's also the East Rift connector, which is what this is, and then East Rift zone off that direction like that. So there is that one, and let me zoom it out, and just in case I freeze, I'll stop talking here. All right, maybe a little smoother that time. So here it is in a cross-section view, that same South Caldera area, Holly Mountain Chamber, although this upper section has all been reconfigured since 2018. But you can see the different depths of volcanic southwest rift and seismic southwest rift here, right, in these two areas below. And as we showed before, here, let me close that. And let's show you this before, as I showed you before. Plotting those earthquakes in the same kind of cross-section, they, once again, let me make it a little easier to see, come up here in that southwest area, or if I zoom it in, you can really see there's the edge of the South Caldera reservoir. Connection to seismic southwest rift is right there, and this is really right around that nexus, right? This is approximate, right? Because I'm not really, this is a schematic. No one really knows exactly what this looks like underground, so it's approximate as well. And the earthquakes are, I try to scale them to the right size here on a map, but it's still approximate, but it gives an idea of where these earthquakes are actually locating. They're not right here next to the surface. They do look like they're much closer to the South Caldera reservoir, which is offset to the south, than a shallower stuff there. So it seems like there's some kind of pathway from here. Maybe this is pulling up some other wing, or something's happening through here where it's trying to inject magma and it's making some space through here. There are some earthquakes that these three towards the surface might be adjustments upwards or not. One thing that we do know for sure is a tilt meter is picking up the swell of the ground in this area. So whatever's happening here is happening within a region shallow enough that the ground is actually bulging above it there. So as we said in 74, it did cause an eruption, but that is rare. More often, it actually goes through this pathway towards the main caldera, towards the summit there. But just to put it in some perspective of how that actually looks. And to rewind to the whole last month, here's how that looks as well. So the oranges and reds are just the last couple of days, and all the whites show in cross-section similar pattern as well. So it's not like we have a new cloud somewhere else, like off to the side. It's actually very well overlapping that same area that was active just a month and a half ago. So that is fascinating there. And so now let me come back to this Google Earth. And what I want to do now is superimpose that seismic southwest rift plot on what we have here for our earthquakes. So let's ramp that up here. Maybe the earthquakes show up better, but there is how that actually looks. And we make it more translucent. So you can, let's see, it's got a good balance there. Maybe see the background as well, right? So there's the main caldera right through there. Halemaumaua in the middle. Kilauea trend goes towards Kilauea. Volcanic Southwest Rift goes off from Halemaumaua to the southwest over there. So right now, here's all our earthquakes. I'll draw a little cloud around them since it might be hard to see. There's earthquakes today. They seem to overlap more so with the seismic southwest rift zone and South Caldera Reservoir than the alternative there. So let's see, that was some of the monitoring stuff. I wanted to show you guys, we did have a question that came in. Dane, let's see if I can find out, read who that was from here. From Dylan Crawford sent us a question. I don't have the stuff to put on the screen here, but he asks, he says that the USGS in their update mentions 1974. Do we think that Mauna Loa could wake back up? Mauna Loa being the eruptive site right here. And that put out this big flow in that direction over here. And so it's an interesting question. In fact, Mauna Loa actually ended in 74. So the parallel is not quite the same, but that era is very interesting to look through. So let's look through that a little bit and just have a little bonus here on some of the eruptions of that era. So let's put on first the whole Mauna Loa eruption, 69 to 74. There it is. This was a 5-year eruption. It lasted, was the longest eruption on a rift zone prior to Pu'u'o. So before that, most eruptions were really short, really like, a day or a few hours kind of thing. And this was what really broke the pattern back in 69, lasting until 74. However, it was not continuous. And many people actually divide this into 2 separate eruptions because there were interruptions that occurred in between this happening. And to show you that, let's step through the sequence here. So 69, this thing is erupting, it's going on, it's kind of happening in the background throughout all of our story here. In 1971, in August, there was an eruption here in the summit. So fissures right along that South Caldera wall, flowed down into Kilauea caldera, went almost to below the volcano house on that floor, on that big plain below there. That was August 71. September 71, September 71, there was an eruption from the summit that opened the southwest rift, the volcanic southwest rift. And you can see here how that eruption went all the way down the southwest rift, right? In September 71. So that was actually something that stopped Mauna Loa eruption and then resumed and onwards there. In 73, it was interrupted again. And that was May 73 at Hiaka and a little bit at Pauahi craters, right in there. Hard to see, but small eruptions there and there, those red ones. And same year, 6 months later, November to December, another eruption in the same zone from Pauahi mostly area, but also all the way to near Pu'uhuluhulu, same Mauna Loa area as well. So you can see a couple interruptions here. We'll put it together here in a minute, but let's just finish retracing the sequence here. September 74, that's this red one up here. That was mostly in the caldera. It's got this C shape and a little bit another fissure that the fissure actually crossed Halemaumaua and put up lava across the upper caldera floor and then also within the pit. So you get that interesting shape like that. September 74. And then December 74, let's zoom it back out. That's the one that's down near where we have our action now, right through there. So if we're wondering what would it take to recreate conditions similar to December 74, where an eruption could happen from back over here, right? If we're curious, could it actually come out of the ground there? What might it take? So we only have this one example here, but let's kind of think through it. We had magma coming through the summit to Mauna Loa. That was the default main way that magma was going. It seemed like there were times there were blockages and the magma did not go all the way through. And those interruptions caused eruptions at the summit and appear in this East Rift Zone connector as well, right? Eventually, the Mauna Loa eruption ends in July of 74, June, July 74, with this eruption followed by this eruption up here at Kīlauea in September on the south side of the crater here. So once the rift zone got cut off and magma was not going there anymore, then you see eruptions. Let's take all these off and put just the ones that happened after the Mauna Loa eruption stops. That would be these ones. So first would be September 74. Let's see if I can get that to show up here. That one right in there. September 74. And then December, right? So the rift zone got blocked. Magma burst through to the summit. The reason that's important is that's what's happening right now. We know the east rift zone is blocked. Magma just popped through to the summit this past month, 1 month ago. And now we're seeing action over here. So might it be that this south flank might move enough to cause a pathway to open to the surface? It could happen. It seems like it could happen, right? But as we've been saying, there is more buildup needed to get to that. And maybe next week we can revisit the 74 eruption sequence once again. We did that, I want to say a couple months ago now, but we can do it again if it keeps quaking in this area up here. So it's a little bit of a exploration there into the earthquake and eruption patterns in the past. So it was really Mauna Loa shutting off over here that allowed activity to then migrate and start working its way to other parts of the system. But do note that even while Mauna Loa was erupting in the middle here, you did get that September 71 flow in a volcanic southwest rift. So you saw signs that something was happening here to open us up already. And one thing that we've noted in the past, and this is not research I have lined up to share with you guys here, is that when Mauna Loa is inflating, it could actually be pinch and close the southwest rift. And after it's done erupting, then it basically can relax, and these areas can then extend more easily. And it might be that you have something happening with an interplay like that, or because Mauna Loa finished erupting, she's now rebuilding, she's not as pressurized as before. Maybe now is Kilauea's chance to adjust its southwest rift zone. And the southwest part of the south flank, especially, which was probably hard to do before because Mauna Loa was getting ready to erupt as Kilauea was recovering from 2018 at the same time. So some complexities happening in there, and this is just discussion with no hard answers, of course. Just to give you guys that are a little bit more interested in the mechanisms here, so a little bit more insight of something to think about over the next week or more as we see what happens with the eruption here. Okay, so that is all the monitoring data we have here. We do want to touch on Mauna Loa a little bit. So let me get Mauna Loa up here on the screen for you guys. We do have a Mauna Loa update from USGS from today as well. They note the rate of earthquakes deeper than 8 miles beneath the southwest of Mauna Loa summit caldera remains slightly elevated during the past month, following a notable increase in July. Shallow seismicity remains stable. All earthquakes are below the volcano's summit and upper elevation flanks, and of small magnitudes less than magnitude 3. Data from GPS shows slow inflation as magma replenishes the summit reservoir system. Everything else is normal. Nothing else to report there. Their monthly update does include more than just Mauna Loa. Hualalai, also normal. Haleakala, also normal. Mauna Kea, normal. Kamaehua Kanaloa, also known as Loihi, normal. Those are all the volcanoes in the update here. They're also monitoring over in American Samoa. Everything's normal over there also. So that kind of wraps up the USGS reports output today. But a little more Mauna Loa here before we wrap it up. Here is the tilt for the last week. Some little wiggles, nothing really major happening. It seems like it's a little bit variable. Zooming out to the last month, you see here's some of that variation as well. We have seen the tilt on Mauna Loa respond to Kilauea a little bit, so we got to be wondering what's happening there. Overall, little wiggles are not anything to be concerned about. It's part of that normal variation you see as volcano refills. Depth versus time for 1 month across the summit. These are the earthquakes in the shallow zones, all through here in yellow and red. Very low background rates. And the ones that were more of interest because they're less usual are these deeper ones that were stronger on early in the month. So you can see why they note that earthquakes are still happening this month, because this month update goes back through all of September, even the early part. Within the last 2 weeks, though, you can see very few, 2, maybe 3 of these events, if you count them. Really, 2 within the last week has been this ongoing, very sporadic activity deep in Mauna Loa. And we'll come back to that again in the future. We did talk about how that's to do with the volcano flexing down under the weight of the mountain as magma is moving its way through at the same time. That's why it makes that area quake extra. So we can revisit that someday as well. Earthquakes per day over the last month. This is integrating all of that. We're really only still reaching a maximum of 6 over the last week, 10 over the last month, very low amounts of earthquakes. We're refilling fairly passively there. This is what it looked like before the eruption in 2022. Earthquakes per week over 400. Here we are like down under 20 or 30. It's really, really low. For 5 years, still quite low. There's a buildup that lasted many years in Mauna Loa, so we're not even into that stage of coming up yet. There is a map of earthquakes for the last month. So here's these blue and purple ones showing this area of where they're happening deep under the summit. And everything else is all spread out, shotgun blast style, like the background pattern you expect there. And cross-section, this is now longitude and depth. So a slice through this upper part, and you see they're all in that base under the summit area right through there. GPS for Mauna Loa for the last year. Here it is. We have a big data gap, but you can see it coming back up, flattening out a little bit. There it is. The up and down signal was coming up a little more. Something happened in between. Now it's a little flatter. For the 5 years, we can maybe draw those gaps a little more cleanly, something like that. So you came up, down, and a little further over. This is a distance north and south across the Caldera. We'll look at this here in a second. The up and down pattern is very similar. It doesn't jump as far up before the eruption, a little bit, mostly down. It's been recovering its up ever since then, and still has not risen to its full swollenness from before by a good amount here. So this pattern, up, down, and resuming and flattening out. And once again, it's been a little while, so let's pull back this data from post-1984 eruption. 84 eruption is this red line right here, right? And you actually have the 75 eruption on here as well. But let's look at this blue line and the pattern you see. This is similar. This is they're using EDM, electronic distance measurements, instead of GPS, but it's the same data really. There it is, stretching prior to the eruption, dropping down, coming up fast, and then leveling out. Then you can see it rose, dropped, rose, slower rose, and then finally starts dropping for good right around here. Now that is about 10 years after the eruption is over. So just to give you some context of what background looks like, this is what background looks like. You expect it to come up and then wiggle and come up higher and at some point stabilize, right? So if we're looking for any activity on Mauna Loa that's going to show elevated unrest, it has to be something that deviates from this pattern. So if it's going up this, and it starts going up higher, now you know, okay, that's something different. We're not in the background, something is going on. But for now, all with an expected background pattern, we've come about that far. Let's rewind it to what we just showed you guys. Right there, there's the same thing coming up. And that's the signals on Mauna Loa. I did want to share. Oh, show that one on just to state in case it wasn't obvious here. There's a 75 eruption, same pattern, up, shallower. In that case, it never started going down because less than 10 years later, there is that up signal that broke the background pattern there too. Okay, so Mauna Loa, what does it look like? Let's look in now. Here is a view from the MK2 camera. They have moved it a little bit. You can see here the outline of Mauna Loa summit caldera, profile of its summit right up there. There is a Mauna Loa weather observatory, the road.
That's not a plume, just a cloud, even though it kind of looks like it could be one off of there.
It's quite common if you live in Hawaii to look at Mauna Loa and see the clouds behind it on the other side. There's many times people in Kilauea see clear Mauna Loa and they see a cloud over on a Kona side. It's just, you see the very top peeking above Mauna Loa and you think, oh, what is that? But it's just the top of a cloud on the other side of the island. Same thing here. This cloud is actually over Kilauea, and looking from Mauna Kea, you can just see the top of the cloud over Kilauea behind the profile of Mauna Loa there. Yeah, it does look a little bit ominous, and but nothing to be alarmed with right there. That's what, just showing you that new profile. Just to remind you what it looked like, I'm going to pull back an image from the eruption. There it is. You see that it was actually panned more to the left. right? And then was before nighttime views, daytime views, and where to put a camera now, shift it over. And there she is, Mauna Loa, looking quiet with a nice sunset cloud behind her there. That is Mauna Loa's monitoring. We do have a volcano watch today, which is Hawaii's volcanoes are quiet and it's a bit spooky. They likely wrote this before they had to put out this daily update today, where it got not quite as quiet. But in essence, they're talking about how eruptions are so common in Hawaii. Eruptions used to be shorter, more frequent, and the longest gap between eruptions on a volcano in the past 100 years was 18 years. But most of the time, most commonly, you see gaps of days to weeks to months to years, right? Rather than long time. So we're already at, if you look back at from today to 1 year ago, we were still in the last stages of Kilauea's 2021 to 2022 eruption. Then we had Mauna Loa erupt. Then we had Kilauea erupt in January, June, September. That's 5 eruptions in the last year we've already had. So clearly it's a different pattern we had before. And it does not look like it's changing, given the fact that it's ramping up again so soon here this week. They do note that they like the periods when it doesn't erupt because they can catch up on all the other stuff, right? Maybe not as much of that this year. Then again, compared to the 35 years of Pu'o'o, where there was hardly ever any break ever, you do get some break now. It's a little bit different. They do note, this is what I wanted to highlight in here, since people often ask, and this is not exactly Hawaii, but this is Volcano Watch, what else is erupting around the world right now? So they put out a list of what's active right now. They do note that in the US, Great Sitkin and Shishaldin are erupting in Alaska right now, generating lava flows and ash plumes in the remote Aleutian Islands. There are multiple volcanoes active in the Democratic Republic of the Congo, in Ecuador, in Indonesia, in Japan, in the Philippines, and Russia. Now, other places only have one volcano erupting at a time. Those are Chile, Ethiopia, Italy, Mexico, and Papua New Guinea. So lots of places erupting all over the world. And that doesn't even count the activity of other stuff on these. They do note something that's you may have noted elsewhere on the internet this past week. The Campi Flegrei caldera that includes part of the city of Naples in Italy has also had increased earthquake activity recently here. And because if you look at the exposure of people in Naples, that's a really big concern. That's a very old city with very narrow roads, and they don't believe everyone can actually evacuate in a short time. So it's important for those people to actually discuss this well in advance, so that if they do need to evacuate at some point in time, they can start well with time to spare, right? Because that's one of our biggest worries in the volcanological risk community is the city of Naples with regards to Campi Flegrei. So that is what's happening elsewhere around the world. This update is posted on HawaiiTracker.com and on the Facebook group as well, so you can go read it in more detail there as well. It is October, Halloween coming up. That's what they're trying to play on here with a little bit spooky thing, but it certainly is true that we note that there are many residents in Hawaii that when the lava is not visible, they do get for real spooked and want to know what the volcano is doing. If there's an earthquake, they want to know if it's coming out near their house again, because that was just so traumatic in 2018. So appreciate the attempt here. And those of you guys who are just be aware, don't take this headline seriously here. It's not really, they're trying to make a joke here. They're not really spooked about the volcano being quiet. They're not that worried. It's more just a time of year. So that said, let's wrap it up here. I think I just have, they do mention here that it's a good time to mention preparedness. So the Hawaii County does have an emergency preparedness page linked in that article, where you can see, for example, they have emergency plans for ohana, for home, for business, things you can print out and fill out, information for disaster, hurricane, flash flood, earthquake, tsunami, wildfire. So check out the county page for preparedness if that is on your mind here as we discuss how many eruptions we've been having in the last year. And if you would like to, just in case, make sure that that's something to have peace of mind, then step through here. So last thing, community events, our community corner. In the national park, there are not any volcano talks this month. There is not an After Dark this coming week. The next one is going to be Tuesday, October 17th, Hawaiian Chant by Auntie Kukuhi. This is the one we're highlighting. That's going to be probably the most packed and interesting one of the series. But of course, there are other demonstrations, hula performances, talks. The talk the following week on Mamaki Tea should be interesting as well, but a little less connected to our mission here, connecting people and culture to the volcano and being prepared for what happens, right? And culture plays a part in that because of all the traditional knowledge. People living in Hawaii prepared for these for years and years and years, many generations. And in some ways, we're kind of catching up here with the modern era and floating in social media. Same kind of thing we're trying to do here.
Yep.
So that is it, Dane. I'll pass it to you, and
Yeah.
we can say some thank yous, talk story.
Yeah, so just want to thank everybody for tuning in today. We rely on viewers like you to help get this information out there, you know, the algorithm and stuff like that, the likes, the shares, the subscriptions and all of that stuff. It actually does help, and it gets it to be seen by more people. More people can see it, and more people are then informed instead of, you know, all the clickbait that's out there, essentially. So we're trying to get the real information out there. And we appreciate everybody that, you know, helps us out. We do take donations on hvari.org/donate. And we also do take super chats to make sure these are tax deductible donations, because we are a 501c3 organization now. So yeah, we're excited about that, and we appreciate all of your support in that front. And just commenting and being here is, you know, if that's all you can do, that's support enough for me, right? But we did have Skyjet Ed come through with a $20 super chat. I want to just show that one real quick. Appreciate that. Oh, it doesn't even show his sticker. He put a sticker on there. Sorry, Ed. But yeah, he's a returning supporter, and we appreciate that continued support. We do have some questions lined up for you, Phil, if you want to try and go through those.
Sure. Let's see what we got here.
All right. Start with Daniel, who asks, since it's been a relatively short respite since the last eruption, would it be possible for an eruption to occur with fewer earthquakes because the road is already paved, so to speak?
That's a good question. If it's coming up through the same place, going on the same road, then that could be possible, it seems like, right? But that is not convincing quite yet, right? It seems like the pathway that opened up for the recent eruption is not the same. It seems to be closed off, or you'd see magma coming back up through the crack already. Or another way to think of it is the end of the earthquake buildup during the last cycle was both that southwest rift connector and the summit caldera both. So we are not seeing the summit caldera activating now, just that southwest rift connector. So it doesn't seem like that's shallower under the summit part is active right now. It could be that the pressure follows the same pathway as last time, and it does go back in a similar area, but it looks like it has to force its way back through there once again. Maybe not from scratch, but you know, in a updated situation, right, where you do have, you know, the magma that went through there the last time, probably push things apart, move those pieces of rock around. Doesn't all erupt. There's always some remnant magma in those cracks, or maybe it's hardened and solidified and is kind of maybe strengthening an area. It's hard to know exactly. But yeah, it's a good thing to think about. I still, you know, the fact that we see the earthquakes happening now and earthquake swarms. Earthquakes occur because the rock is actually breaking. So we've built pressure underground. The pressure can't get out in any other way apart from breaking rock. And that's the bottom line, right? So whatever happened down there, whatever state it was left in after the last eruption, now it has to break rock again to actually do more work. And it started to do that, which tells us that it's pressurized, it's doing the work, but we don't know how that's going to actually play out and end ultimately. So yeah, great question to think about and discuss, Daniel. No hard answer as usual.
Right.
But that's the things to think about.
This next one is from Facebook. It's going to take us pulling up the earthquake map if you want to start getting that up. But Dave asks, says aloha, and he says, I noticed a handful of shallow quakes in the Kona side. What are your thoughts on those adjustments? Magma movement? Question mark.
Those are adjustments. There's no magma movement happening over there. So magma movement, you want to have lots of earthquakes happening in a small amount of time in a small area. Settling events can be bigger earthquakes, one-off, could happen literally anywhere. Yeah, it really could be anywhere. So yeah,
right.
it's I call them settling events, generally speaking. There can be earthquakes that are more magma, like happened in 1929 under Kīlauea. And yeah, you might have had 1,000 earthquakes in a day kind of thing. And like that's what you'd be looking for magma movement. So there are adjustments. The island is really heavy. It's moving, it's sitting on a ocean plate, almost like a human lying in a waterbed, like it kind of creates like a divot. And there's like a gravity, and things are always kind of settling and trying to slide. So there's a lot of movement that happens when you consider that all that's occurring over top of a hot spot that's causing the ground to expand, absorb heat, and then it moves away and it contracts. And so the whole thing is like a seesaw also, and everything's moving all the time. So pretty normal to see this pattern of the scatter plot of background earthquakes all around.
All right.
Yeah.
Thank you, Dave. Another question from Facebook. Lisa asks, is there a site where I can find an actual seismograph? I remember seeing one when the tremor started ramping up before the last eruption, but I can't find it now.
An actual seismograph. So yeah,
well,
I think
I ended up giving the spectrogram link, and she was like, yeah, I think that's it. So maybe that was it, but I want to go ahead, and then I want to try and plug Two Pineapples thing.
Yeah, so the USGS doesn't have a spectrogram link. Yeah. So
Right.
So it depends what you're looking for. Yeah, you kind of look for that data is available on the internet, but it's not as easy to find. The easiest thing is looking at someone like Two Pineapples who have that data streaming. If you're looking for something more simple, the USGS does put out. I can share that. Let's see here. Let me pull up. This is a USGS webpage on Kilauea. And it loads this map, and this thing is notoriously hard to use, and it rarely cooperates on screen here. So let's see what I can do. All these symbols on here are different kinds of instruments, and I believe the stars are, it was GPS. The triangles are seismic stations. So if I come to, let's zoom into Kilauea here, drag this map. And okay, so there is a little cloud is gas. The little red bar is a tilt meter. The triangle is a seismic station. So that one is the sand hill. I clicked on it there. You can click on instrument information, and there it pops up the seismograph for past 6 hours, 12 hours, 24 hours, or 48 hours here. You can click on that, I'll zoom it in. This tells you all different little wiggles here. You can see that in that area, there's lots of earthquakes happening. Maybe some tiny bits of tremor happening through here. But really, when you're looking at events like this, that might be tremor. It's hard to tell with just everything lumped into one spectrum, like you have these old school maps, so just a blue. That's where the spectrograms can be more useful, because you can tell, is that tremor a car driving by? Is it a helicopter flying by? Or is it actually coming from deep underground from magma? Because those all activate different frequencies of the spectrum. And then you have a better idea of what's actually causing the ground to vibrate at the surface. What's the frequency that's vibrating at, more on top of the fact that it actually is vibrating in the first place. So that's where that can be useful to look at Two Pineapple guys, their live streams and that kind of thing.
Yep. All right. So we have Lisa now from YouTube who asks, hey, Dane and Phil, what's your favorite part of the eruption cycle? I can go first on that. Just the early phases when it actually, pops up. That's where really you get the adrenaline and all that, everything's moving. And not only that, the eruption, that's where it's most vigorous too. So everything kind of happens in that first, 12 hours type of thing, 24 hours, at least in these last eruptions. 2018 was a different beast entirely, and we don't talk about that. No, I'm kidding. We do talk about that, but not right now. But yeah, that initial phase really is at these summit eruptions, at least.
I'll go the second phase. The very, very first phase is a little stressful sometimes. Trying to figure out if the magma is going to move somewhere. Is it going to stay put? We've Am I freezing here?
Yeah, you got a little lag going on now.
We've been lucky that the magma stayed put for the most part.
Oh, we lost him. Come on, we'll see if he comes back here. But yeah,
I'm not sure
at
what
least for me.
happened
There he is.
here.
All right, you're
Yeah,
back.
I'm not sure. But yeah, here I am still. Yeah. So yeah, I'd say that second part of the eruption cycle, the very first stages, like when it's opening up, like example Mauna Loa, for example, right? Those first few hours are like, which way is it going to go? Is it going to go down a rift zone? Rift zone is going to go down. That part is stressful. Once it settles in and you're like, okay, it's been 12 hours, it's parked, everything is just coming out now. Now we can enjoy it. That's the part that I think is my favorite, because we've kind of, you've dodged the bullet and you're still early enough to catch all the good action.
All right.
That's different from pre-2018. I'm definitely still traumatized from all of that.
Speaking of 2018, a question from Facebook: do you think it's possible that it is just regulating back to possibly having long-term lava like existed before 2018? So the lava lake up at the summit parked inside Mauna.
It could well be doing that. Yeah, absolutely. It's the normal state of Kilauea is to have a lava lake up at the summit. Right. We know the most recent era of 10 years. We had a big gap before that. But really, if you go back to the early 1900s, the late 1800s, lots of lava lakes all the time between collapses. Excuse me. Yeah, you'd have collapses, lava lakes, return, refill, collapse again, refill. You'd have all kinds of dynamicism happening up there.
Yep. All right, so we got one more here from Dennis, who asks, what are the odds of an eruption in the down drop block area again, offset from the September fissure and possibly up the Caldera wall?
I can't give exact odds there, Dennis. That's a great question. I wish I knew the exact odds. There's a chance.
I mean, that's a true, to me, I'm like, that's a true gamble. Nobody knows the odds, throw a dart at a board and just wherever it hits, call that the spot, type of thing. Like, at least from this far out.
What you can say is it seems more likely than before this last eruption, where you hadn't seen it happen. We just saw it happen. We have a probably similar configuration now. It's probably got a fair chance that it does that, right? We know that the fissures like to open and erupt as far uphill as they can, and that they're kind of blocked from opening up within a lava lake. Or they can, but like that's it's hard to maintain an open fissure underneath a lava lake when all that stuff's pushing down and trying to drain back in there. So it seems to, like, we saw both in June and in September it trying to erupt at an elevation above the lava lake. And so I wouldn't say it's completely out of the question that we see it even further up or in a similar location on down drop block again. I think that's a good insight, a good thing to consider. But Kilauea's got that 100-sided dice.
Right.
You roll it, it might come up anything. There's so many possibilities that chances are it comes up differently than before.
And one of the coolest ones I think that could come up would be a dice roll where it hits on that the road, the Caldera road that collapsed in 2018 and is now inside the Caldera on the southwest side. That if it came up anywhere around that area type of thing and you had it flowing off of the road into the Caldera, that would be the coolest like visuals I could imagine type of thing. So that's the dice roll I'm rooting for.
There's all kinds of cool topography, like that whole area is like, like I remember like being a kid and like making sand sculptures in the sandbox and like pouring water down. It's kind of like that. There's like all kinds of topography. It's all different from before. Even this most recent eruption made a big ridge and a bunch of hills in the middle of that down drop block, and it made like a little bit of a bowl to the south of it. It seems like that we saw Dan when we were up there a couple of days ago.
Mm-hmm. Yeah.
So there's all kinds of interesting topography that the lava could take if it erupts off of the Caldera floor and comes trickling down. So we'll see if we're blessed with that kind of view or not, or how long it takes for that to come around. Seems
to be the recent trend, at least, which is encouraging.
The lava does like to come up crater walls, right? That's why we've seen that's just what you see. It's either crater walls or across that middle zone. And one thing I didn't show on a Google Earth quite as well, but like here is that Kilauea trend. And look, this is exactly where that fissure comes up the down drop block, was right in that Kilauea trend area, right? So it could be that not only do we have this pathway, that maybe this is another pathway that can be activated. And in that case, you see where it leads. It does lead up into this upper Caldera floor here and potentially beyond, right? There are eruptions in Kilauea in 59. There are eruptions in 32. Even over here in Byron's Ledge area, Uealoha. I think it's called Uealoha.
All right. Moving on, we got one last question here from Robert, who asks, is the thermal area across from Puhimau crater showing any changes?
Not that I know. I don't have any data coming in from right there now. We do the Puhimau area is one of the ones that has a GPS, and so that is an area that we didn't mention that's close enough to Caldera is showing uplift as well. But probably more to the point, that Puhimau thermal area started to show that thermal signature. It's been, I want to say, at least 75 years. It's been a long time. So that ground has been hot and plants dying for a long time, and the changes are probably more gradual in that area. There must be some magma sitting somewhat close to the surface that got injected in that time frame, 75-ish years ago or so, to allow that to happen. But it seems like since then it hasn't been any action near the surface as far as that goes. Right, it's a regular. You see heat coming up and gas coming up, and it is changing the surface ecology. But geologically, I haven't seen any evidence of anything changing there. Yeah, that's not part of the regular, what we call the south flank moving and rising south of the Caldera, as we've been discussing for a few years now.
Yep. We did have one last question here from Mark, who just asked, is your Google Earth.kml available for download? Really, this is just like, as far as I can tell, this is mostly just USGS data that is publicly available already. So you got the earthquake layer on there. You have the 74 lava flow layer. These are USGS layers that are publicly available. You have the map, the overlay image on there, which is also a publicly available USGS image. So yeah, I mean, it's more like a lot of our map stuff. It's like mostly just pulling a bunch of public stuff together into Google Earth and then just being able to display what we want to show you when we're talking about it, essentially.
Yeah, it's just having it organized. The short answer is no. I just have not had the time. It might be cool to do that someday if we have enough staffing. But
yeah,
plate's full, and yeah, it's would be hard to keep that updated all the time. But we do have all kinds of layers here in the back end that most of them we can't even load on a screen while we're live streaming because there's too much going on. But
some are so big we just worry about Google Earth crashing even under the best instances type of thing. Like, but yeah. All right. Well, I think that does it for the questions and answers. Thanks everybody for tuning in this week. We will be joined next week with our sign language interpreters, Carrie and Dano. Looking forward to their return. We also had two pineapples helping up on the back end. Definitely check out that 24/6 monitoring page that they have going, and that'll be where the conversation happens when things aren't happening here. We also check out Hawaii Tracker. That's where we operate on Facebook. It's a Facebook group, very big Facebook group, so you'll see a lot of information and other things coming across there. We also post on the Twitter on the pull it up now. It's the
hvari_org.
Yep. And yeah, those are our main ones that we really operate on. And yeah, find us on some other ones. We do have those as well, but those are the main ones. And we do our live streams at 5 p.m. on Thursdays, unless something happens, right? You never know. We're saying the over under is, the 27th, but the under can happen sooner than, we might expect. And if that does, we will go live and bring you the information as it becomes available. I think
totally
that does
guess out of thin air there, right? It's hard to tell what might happen.
Just throw a number out that seems, in the ballpark in the middle, close enough. We did have I did tally up just to see what people thought on that over under thing, and we had 3 unders and 5 overs clearly identified, or no, otherwise 5 unders and 3 overs. So kind of splitting it right there. But we did have a few people talking about Halloween eruption, which would be, a thing that would be
Could
possible.
be, yeah. That's something that, I quite often do Halloween in Volcano Village, and it's really nice when the sky is all orange, which has happened multiple times actually,
Right.
in the last few years. So so
we will see.
Certainly a cool thing there. Yeah. In case anyone is on LinkedIn, I am trying to push LinkedIn. Eventually we might like to stream there as well, but we need to get enough people following on there too. So we do have an HVery on LinkedIn as well. If you happen to use that, then maybe you can go over there and follow our page and help us get that thing off the ground too. The more platforms we can be on, the better. We'd like to recruit in the future some of you young'uns for IG and TikTok and all that. So if you know anyone that's like into that stuff, you can send them our way too. All right. That's all for this week. Nandane?
Yep, that'll do it for me.
Until next week, from the Hawaii Tracker, from HVery, the Hawaiian Volcano Education and Resilience Institute, I am geologist Philip Ong. He is tracker Dan DuPont. And until next week on Thursday, unless we have reason to cut in sooner, we'll see you then. From HVery, aloha.